Okay, so hello everyone. This is a SIG Scheduling Meeting on 16 December 2025. I see we have two items in our agenda. So Wojtek, you are the first one.
Can you give me access to present?
I think you should have an access just directly.
Okay, no, I think you were presenting, so that's why I couldn't. Um, yeah, let me finding the right tab is always. Okay. Can you see that now?
Yes.
Okay, so I think that at least like some of you had a chance to look at the proposal. I just wanted to bring it to the SIG to potentially have some like um, real-time discussions about that, but like I'm definitely happy to take any feedback like later offline too. So the proposal is about like workload aware scheduling, and the goal is effectively to workload aware preemption, and the goal is to ensure that like we not only can like it's effectively an extension for the to the like workload aware scheduling or like the initial workload API and gang scheduling cap, so that we can not only schedule like workloads or pod groups as a whole, but we can also like preempt groups as a whole. So um, the proposal is still relatively simple, which was the goal, like to not start with something super sophisticated, but like start relatively simple and like and incrementally build it like based on feedback and like expectations of our users. So there are like four main pieces there. The first, or maybe like starting from the high level approach, like we are effectively like for the concept of priority, we are going to piggyback on existing things. So we are not reinventing priority itself as a concept. We are building on top of like workload API. So like we define something that I called like preemption unit. So this will be effectively the unit in which will be preempting. For now, the preemption unit is exactly a single pod. And with this proposal, it still could be a single pod, or it can be like a pod group as a whole. Like it doesn't address every single potential use case that we can come up with, but I think it's like let's start simple and then like figure out like what other things we need to do. So the only like potential like preemption units from like with this cap will be either pod or like a pod group as a whole. Um, and the next thing like we are doing or we are proposing is introducing the concept of priority at the whole workload level, pod group actually level. Maybe I will get there. No, so sorry, at the workload level. So we are saying that like again, it's not potentially addressing every single use case, that we can imagine that like, but let's start simple and let's say that like the priority of all the whole workload can only be like, let's say that like every single pod being part of the workload has to have the same priority at the very beginning. Like, so there is like one single priority for the whole workload, and we can like it greatly simplifies um the the mental model that you can have. But we also introduce something that like I call preemption priority, so that like you can also be able to, or you will be also able to represent the fact that that preemption during the lifetime, or the cost of preemption to like the actual cost for me as a user, can differ over time. And like for example, like the best use case is probably like a training workload that is checkpointing every, I don't know, 10 minutes or something. Like if I just checkpoint it, it's probably not a big deal for me if that work or workload gets preempted. But if I'm right before checkpointing, the cost of preemption is pretty high, because like I will effectively lose all the work that my workload did since the last checkpoint. So we, in addition to like defining the priority of the workload itself, we will be able to, or you will be able, or as a user, to define like the preemption priority, and that will be a mutable thing. So you will be able to mutate, or like some workload controller will be able to mutate it over time to reflect the actual cost of preemption. So that's the second bit. I'm not. I don't want to go over every single detail. I think it's like more effective to read it. But the preemption. So the like, if you have any questions, like feel free to interrupt me anytime. And the third thing, the third bit is like how the actual algorithm works, and I tried to make it as similar to like existing preemption algorithm, and effectively it shares pretty much like the high level structure is pretty much the same as for the existing preemption priority algorithm. It's just like adjusted to take into account like whole pod groups or groups of pod, rather than individual pods in many times. So we can take a quick look into that later too. And the fourth bit is like delayed preemption. So this is something that we tentatively put here, but we may consider like moving it to the update of to the updated cap of like the workload API, because the we effectively will make it we are making it or we made it a beta blocker for the workload API, and the reason is that we want to effectively not initiate the preemption immediately when like finding a potential node for the like, or finding the node where the given pod will be scheduled, because like with workload scheduling, when we are processing like m pods within the pod group, the fact that we find a place for like first pod doesn't necessarily mean that we will be able to like schedule the whole gang. So we want to avoid unnecessary preemptions if we will not be if we will not be able to schedule the whole gang at all. Okay, yes, Philip, I see that you have a hand.
Yeah, can I return back to like defining the priority class for the
Sure. Yeah.
workload?
This one.
So like I read that, like, or you said that like we might extend it to the pod groups, so like the granularity is like
Mhm.
more defined. So how do we like plan to introduce that? Like if like do the pod group priorities override like the main one of the workload?
That was my thinking. Yes, exactly. So it's like you effectively treat the workload priority as a default, but then if something on the like lower level like defines its own, like you do define it at the pod group level, for example, that effectively overrides the
Okay, so because like the order will be first pod, then workload, and then like pod group. So
right, yeah.
okay. Um,
So I think whether like the question is like how to what extent we want to allow the individual pods, like to what extent we want to like take into account the priorities of individual pods. Like I think that let's say that we already introduced the concept of the priority at the pod group level. Then the question is like, do we really need to be able to override priorities of individual pods? I didn't figure out any like reasonable use case where it will be needed. So like at the current proposal, we are saying that we will be like kind of like the question is like to what extent we can really validate versus like warn about like divergence. But the idea is that we want to like ignore the priorities of the pod. So like it doesn't matter if we define it at the workload level or later at the pod level, but like the pod priority itself will kind of be ignored.
Okay.
The question is like
So,
whether
so,
like if you have any use cases where this is not true, I'm definitely happy to hear those, but I didn't come up with any, or I didn't find them.
yeah, so I'm thinking about like if you have, for example, there are like a leader worker set and you have like workers and leaders. So like you might have different priorities for the workers and for the leaders, like to say
So
like yeah.
the question is like whether it's really there, because if you have like a different priority for it, like what is your effectively runtime unit is like both like leader and workers. Like if like generally if like any of the workers doesn't work or fails or whatever, like the whole group also doesn't really work. So the question is like whether it really makes sense to have like a different priority for those. Because the leader is effectively like if my workers are preempted for whatever reason, then the leader also will not be able to do its work effectively. So I think that this particular use case, I'm pretty convinced that like they should share the priority, both the leader and the worker.
Okay, so yeah, if you think like it's will not be like backwards incompatible when we override the workload priority later if we need it, and I guess it's fine. Yeah, I was also like struggling with that when like I have the second topic on the agenda, so I was also like, comparing like what to do about like on the pod group and what to do on like the workload level group or on the workload. Yeah.
Yeah, I will try to clarify this a little bit at the captain, because yeah, I think it makes sense. Like especially the fact like how to extend it later and like what will be the semantics and maybe I will like bring the LWS like example here there to like explain why it makes sense. Okay, thank you.
Okay, thanks.
Roman.
Hi. Yeah, I wanted to ask, maybe you just answered it, but I didn't understand. Will the scheduler differentiate the preemption of a leader pod and the worker pods? Will it be aware of the different roles?
I don't think so, or unless like okay, like everything that I'm saying is like just the proposals of like if you have any like specific use case, like please shout. Um, my my proposal is that we will not effectively be differentiating like against them because they effectively form a single group. So like even if my workers don't work, then the leader itself will not be like they effectively form a unit. So like if even if my workers doesn't work, then the leader also like will not be able to do its job because it requires the workers. So so my proposal is that like it will not effectively differentiate. So it will treat like the whole pod group as a single thing.
Yeah, makes sense. I agree with you. The schedule should probably not deep dive into those details because they might also be very specific to the workload type. But maybe at some point in the future we'll need to take this scenario into account, because sometimes preempting a worker is fine, but preempting a leader is most likely never fine.
Okay, so I think that there is okay. So I think there are two bits here. One is the same that we can like introduce that like priority at the like pod group level at some point. Like we can go one step. Like we were like in the initial workload API proposal, there was also a concept of like subgroup. So we can like in theory also go one level deeper and like introduce the priority at like with like divide the individual pod group into multiple subgroups and have individual priorities like at the same like conceptual level at there, and that could to some extent address that. So I think that's another like potential extension. And the other thing is I imagine I imagine that like at some point we will have like additional preemption policies, like not just like the whole pod group as a whole, or all the pods from the pod group as a whole, or individual pods, but also somewhere like in the middle, like let's say individual pods, but only like up to something or whatever. Like I think that there, like we can definitely imagine like more sophisticated policies. I think like the way it's structured, it allows for like doing it like in backward compatible way. So let's just not do that like from the very beginning. But like I think that I can't remember who exactly commented on that, but like the like changes the change to like enum in enum's type for the preemption priority like allows for like extending to different kind of priorities in the future. So I think those two combined would address this use case that you have, or that like this scenario that you have with leader worker set. I wanted to make it like simple at the beginning, so like to ensure that like we move we like move more incrementally, but I will try to like describe that a little bit more, like, or describe the potential future in the cap a little bit more.
Definitely, I agree. I think that further hierarchical structure of the workload will probably solve it. So it sounds like a good direction.
Philip?
Yeah, so just one idea came to my mind now. Like if like so we presume that it's the pod group priorities like might be defined in the future, and there might be and it might affect like the priority of the whole workload. So maybe basically we would override the workload priority, but it might be we might be able to reason about the workload as a whole priority as well. So we could infer like what the workload priority of the whole workload is according to the like pod group priorities. So would it make sense like to just add like a status field to the workload currently and just copy the priority we have in the spec, and we would say we are reconciling this status, and then like we could in the future, if we need some like more difficult rules, like we could just update our controller to reconcile the status, and people would just read the status, and it would not be backwards incompatible what the actual priority of the whole workload is.
So yes, I think that there's already like an unresolved like section about the status, and it's not exactly what you said, but it's like along those lines, like that's mentioned there. So yes, I think I will think about it a little bit more, but like conceptually, I agree we need a status, and we need to like somehow reflect the actual priority there. The question is how exactly, but like if you could like comment on the PR itself, like in that place, like your thoughts, that would be helpful too. So
Okay, yeah, I will do. Yeah, I read the cap, but I didn't have time to read through all the comments
sure.
you had there. So yeah, I will try to do that. Thanks.
Thank you. Okay, any other questions from anyone?
Yeah, Wojciech, one more question. Maybe I'll just raise it. Maybe it's fine, but I wonder if there is a potential race between the workload controller trying to change the preemption priority class name, and possibly the scheduler acting on the information that it captured.
It is.
And maybe it is okay because it's like it acting on the latest
yes
configuration it has.
So there's definitely like it's by definition or by design like the eventually consistent. So yes, it's definitely possible where that I, as a workload controller or as a user or whatever, I already changed the preemption priority, but scheduler will use it we'll use still the previous one because it already started computing or started at the same time roughly. So yes, there's definitely a race. I think it's fine. How we are going to one thing that I wanted to do is for that is like effectively to have a status field in that that reflects the current preemption priority that scheduler is using. So like until you as a user or as a workload controller or whatever observe that the status already the priority in the status or preemption priority in the status reflects what you ask you should assume that the last update or last n updates or whatever didn't make an effect yet. So yes, so I guess the summary is yes, there is a race. I think that it's okay.
Yeah, sounds good. Is there time for another question, or do you want to proceed with presenting the cap?
No, I think that I more or less described at the super high level what I wanted to share. I think it's more effective to get talk about questions.
So there is one scenario that I want to bring up, and it relies on some understanding that I have about the scheduler implementation, which might be not very accurate, but I wonder if it is going to be implemented in the gang scheduling plugin, right? And if it is so, I wonder if there might be a problem with running multiple schedulers, or maybe to keep it simple, multiple scheduling profiles, where one scheduling profile has gang scheduling enabled and another profile without it. So the other profile might possibly perform a pod priority preemption, the one that already exists in the scheduler, and evict some of the pods of a workload that was scheduled by a different profile that has this gang scheduling configuration, and it might violate the preemption policy that was configured.
Okay, yeah, I must admit that I didn't think about this case at all. So
it is, maybe it's a good time to suggest or to rethink if one profile can,
or whatever,
if it can even, if it's even a valid configuration that one, or valid preemption between profiles. I can argue that it is not, but
yeah, it's at least conceptually it's not valid. The question is if we need to do something about that, or if it's okay to just say if you configured your scheduler that way, then it's your fault. But let me think about it. I don't have an immediate answer from the top of my head now. So okay. I noted it for myself, and let me get back to this. And I will definitely update the cap with some answer. We may discuss later if that answer is good enough, or we should.
Yeah. And maybe if it's not the right scope, maybe we can discuss it regardless of this specific cap, because there are several issues that were opened in the past about this exact situation, not in the context of gang scheduling, but in a general context of one profile or one scheduler evicts pods of another scheduling, and there is a conflict even without gang scheduling, and especially when it's the Kubernetes default scheduler and external scheduler, then it becomes even a more severe problem. Okay, if you have any thoughts, or if you want to continue talking about it, I'll be happy to do that.
Sure. Philip?
Yeah, I just have like one question about the domains. So, like from what I understood, is like we now want to consider the whole cluster as a domain, like where we will try to like remove pods until we get to the like set of pods that we want to like disrupt. So is like do we so like now we will not use like the scoring of nodes that we have currently that allows us to basically select the nodes that we will want to use for like the preemption. And so are we going to move this the scoring like to all to the pods themselves?
So I think we can't just ignore the existing scoring. I think it will more be like a combination of existing scoring, node scoring, because like you still technically still can have like multiple options like within the same set of preempt or like victims or whatever. Like you can still potentially like choose different nodes, and so I think that we need to take into account the existing node scoring functions too. It's just that will not be the only factor. So like it will be like a combination of that and like the actual well, maybe it doesn't make sense what I'm saying. Oh, so I guess like what I wanted to say is that like conceptually or in the first version, like where we have this algorithm where we choose the victims, like once we like to check whether like a given set of victims is feasible, or like once we chose the set of victims, like choose like finding a placement for the workload will include or we will use the actual, or at least the existing scoring plugins for nodes will contribute to how exactly we schedule the pods in the victims. So it's just like it's not we are not choosing the nodes. We are not choosing the node for like nodes for preemption based on node scores. We are just like scheduling into those using the node scores, or scheduling the workload using the scores of nodes. Sorry, I think it's like a little bit chaotic what I'm saying, but what I'm trying to say is that when we first like, or the algorithm is basically that for we somehow choose the like set of potential victims or set of victims that we want to preempt, and then check if we can schedule our workload there or our pod group or whatever, assuming that all those victims go away. So for that, we will be using the node scores, the existing node scores, to figure out like where our new workload pods should be scheduled, because that's effectively like a regular scheduling. And this is the place where the node scores will
Okay, so I guess you will use the like when you are like sorting the pods, you will use the node of that pod to get the node score, or
can you say it once more time?
so you need like to decide like what kind of pods to take to like as the victims, and like we know like the nodes of these victims, and so we could use like node score of like to compute for the node of each like victim.
Yeah, I think that like still the priority of the victims is more important, but within certain within a given priority, yes, we can like, yes, we need to figure out like all the details. I was hoping to leave those a little bit for the implementation, but something like that.
Yeah, okay. Yeah, I was just wondering like if the scoring goes away completely or just like we.
No, it
yeah.
It will not be the most important factor, but it will appear in there. Like I don't think we can like just ignore it completely.
Okay, thanks.
Okay, I think we have like one more topic, so I don't want to consume the whole meeting. Like I'm like if you have any other comments, I'm happy to take those offline. But I think Philip, it might be like good time for you to present your topic now. So thanks for all the feedback. I will try to adjust the cap based on that later this week.
Yeah, my topic also touches the preemption, so it's a bit connected to this one. Yeah, I don't know, like if you just want to click on the link, I have just like two small sections in the cap that we can go over, or I should present.
Yeah, I think it might be easier for you to present.
Okay. Okay. So I don't know like how much you are familiar with the eviction request. So yeah, just to like give a short info. So basically this is an API that tries to evict pods like in declarative manner. So we have like a set of interceptors on each pod, and then we create this eviction request object, and we give a chance to each interceptor to like perform some logic before the pod is even terminated. So it could be like a pod migration or yeah, so or like checking some external systems. And then the result we want from these interceptors is that finally the pod is terminated. But the main problem like for like scheduling and preemption is that the interceptors can take a long time until like they perform their logic. So this could be like in the order of minutes or even hours or days, which is not ideal, for example, for the preemption scenario. And currently we have like the cap is a bit simplified. Like I uploaded that yesterday, but we just now like when we like the only static information we now have is only the name of the interceptor. So this is like the subdomain defining like the interceptor, and it's on the pods. So like from scheduling perspective, we don't have much information about the interceptor, but like one of my proposals is like adding more data to this interceptor. And during runtime, each interceptor identifies like its own progress in the eviction request status, and like we basically require a heartbeat from the interceptor, which tells us that it is working, and the expected finish time. So these are the two most important things. And yeah, I will go into what we want to do with regards like to the workload API and to the preemption. Okay, so like first thing is that like we still don't know how the like disruption of a workload should work. Yeah, Jack.
Yeah, I just wanted to ask if like about the interceptors, do they run in parallel or do they run like serially? Because like
Oh,
the reason I'm asking is this is the field like about expected time, the like time when it finishes. So I think if they run in parallel, that makes sense because we can take the max as
yeah.
expected. Or
Unfortunately, no. So the interceptors run like sequentially currently. I guess we could add that option in the future, for some scenarios.
no, I think that the sequential like nature is what I would do personally too. But then the only concern that I have is that the expected time when it finishes is not super informative because we have no like if it's the last interceptor, then yes, but if it's not the last one, then it's not super informative for the like end user because like the next interceptor can take another hour or day or whatever.
Yeah,
So
yeah, I know. Like this is like, yeah, this is the premise of the problem. And yeah, I just want to say like the main reason why we have like this serial execution of the interceptors is that we use this as like a point of synchronization. So we have like the eviction request controller that decides what kind of interceptor is running at each time, and we have like a lot of scenarios that's, for example, you could say when you have a disruption, we want to first like auto scale or scale out of for the workload before we do this disruption. So we don't like, so the application itself doesn't feel any disruption. But the entity who is doing the scaling out, it's not decided. Like it could be like an HPA, horizontal pod autoscaler. It could be, for example, a deployment controller or other controllers, and we are not sure like uh, what kind of controller wants to like perform their logic above some other. So that's why we have the serial execution. But yeah, but we might be able to like extend it in the future if we need to. But yeah, but the disadvantage is that we don't know how much time it will take, and we don't know even like when each interceptor is running before, because the other interceptors didn't have a chance to run. And so like one of the examples where you could see that we cannot estimate this time is, so for example, if you are like migrating like some database or something, this depends on the size of the database, or also on the on the speed of the network. So you could have some estimations, but you will not be sure how much time this should take. So that's like the like pretty big disadvantage for the preemption scenario. But yeah, but let's first talk about like the workload adoption and how we want to disrupt workloads. So like in the alpha version of this cap, we decided to uh, basically disregard any pods that are part of the workload. So on admission, if we create an eviction request and we want to evict a pod and it's part of the workload, we will like fail on admission. So we will try to like plug in the support for the workload later. So it's much easier for us to progress and just target normal pods. And then like I just want to like I sketched some ideas here how we would like to add the support for the workload later. So like the same thing like when you were discussing the priority classes for like the workload level or like the pod group level, we need to decide like what is our like disruption unit. So if like there are like basically three cases. So one is, okay, we can work as normal and we can disrupt pods like one by one, and the workload will be okay with that or will reconcile and just replace these pods. And so this can be even like for the workload that doesn't have any like gang scheduling capabilities. But I guess even for the gang, I'm not sure like if for the gang scheduling, but that's not the point. Like we don't know like how the evolution of the workload API will happen. So this is one of the options. And the second option is same with priorities, have the workload level disruption. So basically not allow any disruption of pods unless we want to disrupt all of the pods at the same time. So like since we will be blocking this on admission in alpha, like we can extend this to still block like eviction of pods that are part of the workload and require like people to disrupt the workload. And the disruption of a workload, yeah, I will show you what we have here. So right now the eviction request is written in a like a generic way that you need to specify a target, but the interceptors part and all of this could work like for any object, not just a pod. So right now we have only the eviction target is a pod, but we could add like a workload reference where you would say where you could create like eviction target to be a workload, and we would yeah, the how to implement the eviction of a workload is still not decided, but we could use this API to do that. So you could, I guess you could add interceptors also just on the workload level. So what we have now here on the pod level, we could have interceptors on a workload, and so we could have only one entity reacting to the disruption of the whole workload and deciding like when it is okay to disrupt it and how fast. And the third option is to have this also on the pod groups. So we would for example, have some pod groups that allow disruption on the pod level and maybe on the pod group level or on the workload level. So it's a similar thing. And yeah, so we just want to see like what are your thoughts about like these new features that could come your way. Or let me explain any details you want to see. I know I just skimmed through all of this, so I can explain more about the eviction request.
So from my perspective, like I think it conceptually makes sense. I think it's like at the conceptual level, it's pretty aligned with the workload, the word preemption. So I think that's great. I think we just need to ensure that we have also alignment in terms of like the exact API and so on. But like I will take a look like offline at the proposal. I think that at least conceptually, I think that all makes sense to me what you just described.
Okay, cool. Yeah. So yeah, the main thing is like we are not doing anything yet. Like this is still a rough sketch, so we will probably have like a whole cap for that, and we will bring that like in future releases. Just so that like SIG Scheduling is aware that we plan to do such a thing in the future. Because since we are ignoring the pods of the workloads, like we want to bring this to the workload, so so you can disrupt like basically every pod on each node.
Yeah, but I think that like the what you call disruption unit and so on, I think that's pretty aligned and like conceptually the same thing that we are like, or I was proposing in that like workload over preemption. So I think that's great. I will take a look. I think I'm PRR on your like cap anyway, so like I will be taking a look into that anyway. So I will think about that also from the API and convergence perspective. But like at least at the high level, it seems to be like pretty tightly aligned. So
Okay, cool. Yeah, great to hear. Yeah, I just want to bring this for visibility mainly. But yeah, thanks and also for taking a look. Yeah, I guess we can also talk a bit about more the preemption support. So this is this is the more difficult one since it has like the backwards compatibility and like issues with basically like competing interests, I would say. So one of the interests is to schedule a pod, like the new one, the preemptor, and like the competing interest is for the other workloads to basically gracefully terminate. Or in our case, we would like the interceptors would like to have a chance to run before the preemption. So this is not easily reconcilable, and like we have like multiple options what to do here. Still not sure like what kind of direction is the best. But so the first thing is like how do we approach? How do we want to approach like the scoring part? So like or like the prediction part, or how much. So if you have like two workloads that's are like with the same priority, or I should say pods or workloads, but that doesn't matter. So if they have the same priority and we need to distinguish between them, like what kind of workload is easier or better to be disrupted. And as I have shown, we don't have this information of the eviction interceptors, but we could add some kind of metadata for each interceptor, how much time this interceptor is expecting the interception or the disruption to take. So we could add the same thing we have in the status. We could like force interceptors to give us this information beforehand on the pod level. So like one of the options is having like the expected time, or another option is having some kind of a weight. So I don't know, like what values from like 1 to 100, but this is very difficult for like, because the interceptors don't know the other interceptor, so it's very hard to do that like in a global scale. So I am more in favor of just having the time to see, like you would basically sum all, make a sum of all the interceptor finish times, and then you could know how all basically have this like a plan of the whole disruption, how much time it should take. Yeah, Wojciech?
Yeah, I think that time is like much easier to reason about. So I am conceptually also very heavily like on the side of time, the same as you said. The only potential concern is how close to reality we'll be able, or the interceptors will be able to set it. Like I think it's a little bit similar problem to how like workload autoscaling work, or like vertically scaling pods and so on like works. Like people when people are like setting how many resources they do, like humans are pretty bad in that. So like when like I think it might be like quite similar problem here, that we may not be able to like estimate it well, but I think that that's a separate problem. Like at the conceptual level, I think that time is what we should be targeting, and then like we should separately figure out like how to ensure that it's as accurate as possible.
Yeah, just want to respond, Maciej, before I forget. So yeah, like we cannot estimate that. That's for sure. Like it depends also like how each interceptor is cooperative with us, and so it might be blocking a lot. And I guess there's a similar problem is like with the like in some sense with the like graceful termination period seconds, where you also have some sense like how much time it will take, but you still don't know like exactly. So I guess one option would be adding some like preemption strategy or preemption weights but this would be also like we would basically just depend. We will always depend on the like the good behavior of the interceptor. So even if we add some other kinds of toggles, we still it depends how best you tune your cluster. Yeah, Maciej.
Yes, I have a question. If we should really deprioritize the pods with interceptors, like, right? So we base the preemption on the pod priority, and then we would make it even more granular with the expected time to finish, like time to evict the pod. Like the question is if we should really do some that kind of sorting, or just do it only if the user specifies that explicitly that they expect that we will sort those pods by the interceptor finish time.
I think like firstly, it would be better like if we like skip the pods with interceptors, because if there is some like graceful termination, we might want to like keep that. But this is but we almost like this is mostly talking about a case where we have like two pods that each of them has interceptors, and how to compare these pods.
Yeah, so that it depends if the user wants those pods to be preempted ASAP, or they can even wait a bit more time. That's the question if we should really prioritize preempting the pod that will be available the earliest, or just do it more randomly. Like now the scheduler doesn't care about the graceful termination, so it just chooses the pods based only on the pod priority.
Yes, so
So
so the selection of these pods and how to implement that is also like the second part of this like paragraph. And yeah, so like firstly, like we would like to like prevent like disruption of interceptors if we can, or like because if the pod has an interceptor, probably there is some reason for that. But as I said, like we can add more metadata, like maybe some interceptors are not as important as others, and we might like see that like in the future and see, okay, this interceptor has maybe just does some logging, or it's not very important, and we might want to disrupt that. But this is like, this is like the future. But for in the beginning, like we have to decide how we want to disrupt these pods with interceptors. And so one of them is like one of the option is that we would allow some time for the interceptors to run. I don't know basically how this is feasible, like from the like backwards compatibility perspective, since as I said, like the interceptors can take, for example, hours, but this like if we are okay with at least having some delay before like the preemption and the pod like deletion and termination. And the second option is to add a new preemption policy. So this would be on an opt-in level. And basically the preemptors would decide that they are okay with waiting. So I guess this could be also configurable, but maybe in the beginning we would just expect the parameter to wait indefinitely until we can schedule it. Yeah, so these are just some sketches, so please interrupt me.
Yeah, okay, yeah, thanks. I need to read through this cap as well to have the more background. So yeah, for now, thanks for that.
Okay, yeah. I would it would be great to see some feedback on that. Yeah, as I said, like it will be done in the future stages, so we are not planning to push any like preemption or workload changes in this cap. So we plan to target this cap for like 136. And yeah, so basically this is just so we are aligned on these changes. Since I know, like for example, now you are looking at the preemption from the workload level, and there is like this section about the delayed preemption. So like if we are delaying the preemption, it would be good to consider if we can also delay. I mean, to have a point in time where we create, for example, the eviction request and then have a wait time for the preemption to basically complete.
Okay, so if there are no more questions, I think, Philip, do you want to finish your topic, or you have anything
Yeah, I
more?
think that this is all, and we are on top of the hour. So yeah, please take a look at the cap, and we can discuss the future plans there.
Yes, thanks, Philip, and thanks everyone for joining today. So, have a nice day and see you next time.
Thanks.
Thank you.
Thank you. Bye bye.